So far then, what we've done, we've got our airtightness membrane on. We've gone through the fixings, remembering that we try to keep these fixings to a minimum. And when we do fix, we fix within the overlap or the taping zone, if possible. We're going through the taping process, making sure that any creases and everything got taped in so it doesn't create a straw or somewhere where the air can travel through. We've got to make sure that's got good adhesive connection. We've done our windows, taped around the window for a airtighted window, which we've done. And we've done the door, and we cut the door, folded it round, taped, and again fixed where we can tape over or overlap. We've also used that piece of waste that came through the middle to patch and fill in upon the door head, bearing in mind that we have to remember that we keep the corners nice and tight. Use a piece of timber or something, steel rule, anything, which will keep it nice and tight into the corners while you're fixing. And then we've taped that. We've checked it over to make sure that we're happy that that is as airtight as we can get it. The next thing is, why do we do airtightness? We need that because that is a central part of controlling the environment which we're in. We've covered that many times and we'll do again. But what do we do to this now? There are a number of different things we can do. What we have to do, though, what we think about is how do we get services into the inside of the build? We need some way of plasterboarding or internal boarding. We don't want to go directly onto the membrane. So we create service board. I've got some tuber one, 25 by 50 millimeter tannalized batten or lark, depending on what you term it. Now usually this would be fired on with a nail gun, probably 63 minimum length nails, ring shapes usually, fired on about 300mm centers to carry plasterboard. We would put one of these on everywhere there's a stud on timber frame. The advantage with the Intello is we can see the joints and nails behind it and know where all the stubs are. Failing that, if we were using a different membrane, we would have to mark the membrane before we put the overlap onto it so we would know where they are. And it gives us that bit of control over getting the centers correct. I'm not going to nail it on. I'm going to put a couple of screws on just to demonstrate at the moment. So it off. Okay, only come to a door, keep it flush to the inside. That means that any boarding, you can finish it and return tight on as soon as you're there. That means that you can get good return into the window. If you need to come out further, then that should be dealt with just simply by running the board out or putting another piece of batten on at a late date. Same applies to the windows. Flush all the way around, and this creates a 25mm service board. It's usually enough for electrics, small plumbing, that type of thing. Sometimes you may have a specialist request of, in the design of a particular truck, a duct dig or something like that. You may need to build this out. The 25mm batten we've got here is just what we do as standard. If you wish to come out 50mm, 100mm, you can do that. Just obviously use different fixings. The thing to remember though is when it comes to electrics and plumbing and other services, we have to remember that they could do potential damage to the materials that we're putting on the membrane, as they often do. When they drill something or they're cutting something, they tend not to always take into consideration the damage that they could potentially do. it's important that if there's any damage, which will happen at some point, that it's dealt with there and then. Don't leave it. Don't think, oh, I'll do that later, because you won't. Deal with it there and then. And also, train and instruct your people coming to site what they need to do to maintain an airtightness membrane. And stress the importance of damage. If they do accidentally damage it, you need to know straight away so you can deal with it straight away and make sure that that airtightness is as best as you can get it. Service buoy. These are normally, again, go on with a nail gun, bang, 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 whatever sentence is required. Usually about 300 mil on an internal counter fasten. And that's all. That's your introduction to airtightness and internal membrane.
John, when you're applying the airtightness tape, it seems quite easy, but how have you found new people in the industry picking up this skill?
When it comes to taping, it's a particular skill that requires a certain trade of thought. Not everybody's good at it. It's not a difficult process, but it's a process that needs to be quite methodically done. So therefore, I think if you would have 10 people, you may have 2 or 3 of those which are actually really good at airtightness. So potentially you may need to pick the people to do these jobs, even though everybody could do it. And but not everybody has the patience to do it, because you do have to be quite methodical in the way that you do it to achieve what you need.
Yeah, so really important to get the right methodical approach installed into the people who are actually doing it, and certain people are more capable of that. You mentioned a 0.3 air change that you've been able to achieve. Just remind us, what is the standard, the air changes per hour for airtightness, standard for Passivhaus?
Well, the airtightness for Passivhaus, we always aim for 0.6. That's what we aim for. Some times we get a lot lower than that. Now, the air changes is how often that, obviously, the air changes within the build. Regulations say you can have is 10. We want it to be below 1, potentially 0.6. The lowest count I've ever had is 0.286, and I'm being very accurate there, and the figures are very, very small. But that is the lowest one that's been recorded on something I've been involved with. And we can normally achieve 0.6 quite comfortably if we follow the rules. And the smaller the air change, the better we can control them.
Excellent. You mentioned a negative air test. Do you just want to explain that in a bit more detail for us?
During the air test, potentially for Passivhaus, they often do 2 air tests. Once you get to a first big stage, or this stage, and everything's ready to be tested, windows are all in and taped up, you do an air test. There's a positive air test and a negative air test. Pretty self-explanatory, really. Your positive air test is where they pump air into the building and pressurize the building. And then they will monitor the amount of air that disperses over a given amount of time. And a negative air test is obviously where they suck the air out. And you can actually watch this bow in like the balloon and suck in. Which is why it's important to make sure your fixings are covered with tape or wrap, because potentially you could pop a fixing, a stapler, which will need air tightening. So then again, they'll suck the air out and monitor how long it takes for the given amount of air to come in over a given amount of time. These are tests that are done by a specialist, people that do this, and understand the mathematics of what they need to do to achieve it. But they take both their tests and then they put it together, and that the average of those two tests will be the air result to which you get.
Excellent. And from your experience, John, what might you see in a positive or a negative air test, and how might that help you, ensure the quality is there, and, what sort of steps might you have to take, or things that you have to revisit?
Yeah, when we do two different air tests, I like that approach, because what that does is it tests the strength, tests all the junctions and the tape joints in two different directions. If there's low breakdown during that test when it's all sucked out and ballooned in, pushed against, and it holds and it gets to the correct standard, it's a good idea. There's a good chance that it may actually retain that for the lifespan of the build. But if there is an air leak somewhere, especially with a negative test and it's sucked in, you can quite often actually hear it or feel it. If you're in a build and they've sealed it off and you can feel the air coming around the window, sometimes you can hear it. The easiest thing to do is, if you do a positive test and you're not achieving the leaks, is not achieving the standard that you wish, you can use smoke pencils or something like that, which will create something that will be affected by a drop. Smoke pencil is an excellent way of doing it. Just a little pencil, you light one end, and you get a steady stream of concentrated smoke. You can follow that. It should just hover around. If it's got movement, you can follow that movement, and you can find where it's leaking. Most of the time, this is either doors or windows. That's where you get most leaks. But potentially it could be simple thing like we've forgotten to tape over a soil vent pipe during the test or something like that. Because quite often, if you get all the little holes and all the little leakages and you put them together and you've got something the size of a can lid, that could potentially be a fail. So attention to detail and track down any issues you got during the testing. That's why we test, to find out the issues and confirm it does exactly what it's supposed to do.
Good stuff. So this really ties in with the importance of quality control, and this is one of the key themes of Passivhaus and the standards of building to Passivhaus. So yeah, really important part of the quality control procedure. I just wanted to pick up on something that you mentioned. You mentioned racking strength. I just wanted you to sort of explain that a little bit and just, go through a bit of the detail of what is racking strength and how does that help, in this case, the cassette that's been built here.
Well, the racking strength isn't actually anything to do with airtightness at all. It's to do with the structure, the strength of the structure. We have here a insulated panel, which is basically I-beams, which are vertical with a frame around it. Now, this is actually mobile. Not a lot of structure to it, as in sideways movement. So the boarding to which we use will be screwed or nailed on at certain centres on each stud to make sure that it doesn't move. And that is your racking, to prevent that. And your racking strength comes from how much that particular board can take before it gives way for that racking. Which is why racking strength cords will be designed purposely for that project. And centres that nail it, as they're normally nailed on. So the centres are crucial to maximising the strength. Some boards is 225mm centres, other boards will be 200. These particular ones on the edges is 100mm.
Yeah, so there's a variant in terms of racking strength. In design. Excellent. You mentioned overlapping on the Intello membrane. Just wanted to ask you to just go through that detail a little bit again, if you could, just to really spell that out exactly what you're looking to do on the overlapping there.
Well, on the overlapping, when we get the overlap. Every product and every manufacturer has a way that they would prefer you to do it. You will get instructions every time you open a roll of membrane. There will be instructions in there. This one gives you your 100 mil overlap. That overlap means you've only got to take once. Where you get this scenario, where we've got a joint, we have to take twice, because we have to take the edge and then tape to the tape to compensate for any lack of overlap. But here also gives us the opportunity, of course, to incorporate wall fixings and stuff on the overlap. The thing to remember is when it comes to a vertical overlap instead of a horizontally, potentially you can get a wavy line, out square, or whatever. So we always allow more on a vertical overlap to allow for that. I always say 300 mil, because some membranes are particularly difficult to cut and don't always have the marks on it. This one does, and it could be out of square and wavy. So therefore, I always say a vertical overlap should be greater than a horizontal wrap.
Excellent. And so you mentioned the window overlap and how the tape is what you're overlapping, and you have a little bit better quality there, so you don't have to have the same distance on the window.
Yes, as any edge. I mean, this edge we've got here on a window, it could be on the door, it could be any junction where potentially you can't get an overlap or haven't had an opportunity to do an overlap. So it'll be a tape and then another tape over the tape. So we have two different directional fixes via an adhesive tape.
Excellent. Just to flesh it out a little bit as well, you know, we've looked at the detail that you've done there on the corners. Why is it important not to fold round the corners?
It's just for when it comes to taping, I tend not to fold around the corners because you're overstretching the tape. And also it's difficult to do. If you cut straight sections and infill the corners afterwards, it then gives you an opportunity to be able to get a very good seal on your tape and also to pull it in nice and square. So it's just a stronger, better seal in my opinion.
Yeah. I noticed as well that your strategy with the clout nails is to do them just on the edge so that you can actually use Intello membrane to cover them. And you also mentioned about potentially using squares to go over clout nails.
Yes, I mean, it's when it comes to fixing the materials, we try and incorporate your nails within overlaps or taping areas. Therefore, as soon as you tape or you overlap, you've got the airtightness in. Sometimes it's not possible because we want to pull that cord. We want to get those creases out as much as possible. So there will be, on occasion, a nail or a staple or a fixing of some description that is on what I would term as an open face. What I do with the airtightness, I always put a little bit of tape over it top. Just in case during the testing it pops, or just in case that it's created a hole in some way. If you've got 50 staples in a house, potentially that's a little bit of an alley. So if you tape over your, just play them in safe shot, and the belt and braces are finishing that with little attention to detail can sometimes make a big difference.
Yeah, so it's having a fanatical interest in the detail, really, and just really ensuring that there's no stone unturned, so to speak. You mentioned about the space between battens and how you might have 300mm centres and 25mm service voids, and you also mentioned about variances in terms of the service void. When might you have variances, and when might the centres be different, and why?
Well, the centres are often different. Sometimes these panels are actually 400mm centres for the sticks or studs. So therefore, the battens, the counter batten, or the last, will be placed on every single stud in every direction. regardless of it's horizontal or vertical, it will have a batten on to carry the boarding. We tried to keep the centres either to a 600 or 400 mil cent because it works out mainly for the board, so it means less cutting and less wastage. But it's not always possible. It will depend on the design. Sometimes they have to have closer fixings. But we always, every stud has a counter batten on. Now, we can use anything we like to create a service void. Depends on the services to which we're putting in. 25 millimetre, 90% of the time, and even more than that, is sufficient. However, there are times you get a specialist electronic controller or a box or something that needs to go in behind or hidden behind the wall. So you can, in effect, make a stud work in front of this by coming out further. You don't need to insulate that, but what you can do is this coat band will be designed for purpose. You may have one wall with 25 mil, you may have the opposite wall 75 mil, because you've got a particular ducting that needs to run down through there. I have had it in the past where we've had specialist electronics go into the build where they can control everything in the house and via their phone anywhere in the world. And some of the ducting was about 65 mil deep, carried out a specialist fibre optics and the cables. So what we did is we just put a 75 mil timber on edge and fixed it exactly the same, but with screws instead of nails. And once the wall was done, it was all hidden and everything else. So you can use it almost as a boxing if you need to.